Welcome geometry students to class today on Tuesday the 28th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's quickly look at some announcements. While I'm making these announcements, go ahead and get out your notebooks and pens, pencils, calculators, book, and let's get ready to get started. A little raspy voice tonight, so you'll have to kind of put up with that, unfortunately. There will be a quiz this Friday. I will give you more details about that quiz on this coming Thursday. So on Thursday, I will give you details about a quiz this Friday. There's nothing to turn in. You owe me no homework. I'll tell you what though, I didn't go through the stack of tests yet. Okay, I did not go through that stack, but some of you might not have remembered to turn in your review sheet. Now, if you didn't do it, that's fine, but if you did, you get 5 bonus points. Okay, if you turn that in. So if you did the review sheet, please turn that in, Haley, Jasa, or Jake. And I'm thinking, Jasa, I got yours already. I'm pretty sure. Yes, I got yours already, so you're good there. Please turn those in if you have them done. And then announcement number 3, we will go over your tests on Wednesday. Understand, I did not get your tests until tonight, Monday night, so last night at the basketball game. So I got home at around 9:30, 10 o'clock, and obviously I can't grade them and make the video and all of that before I go to bed. So we will go over your tests on Wednesday, so be ready for that, and they'll be passed back to you on Wednesday morning. Let me get a drink of water here. And without any more hesitation, let's go ahead and get started. We have a pretty short video planned for today, so also you'll have homework tonight that you need to do. So let's go ahead and get started. Chapter 8 is actually a pretty easy chapter. We're going to be dealing with stuff that really quite often is covered in middle school, areas of squares, rectangles, triangles, areas of parallelograms, trapezoids, circumference, and areas of circles. Angles inside of polygons, classifying polygons, stuff like that. And if you can memorize the formulas when it comes to the area problems, I think you'll do pretty well on this chapter, okay? So that's pretty much what chapter 8 is all about. The title of chapter 8 is Polygons and Area. That's the entire chapter 8. The lesson today is called this. Would you please write this down? The lesson today is called Classifying Polynomials, lesson 8.1, and the date today, if you like to keep track of that, is the 28th of January 2014. Okay, classifying polynomials, lesson 8.1. Now from here on out, you know how I roll. I go really fast, or I try to go fast, so just pause the video when you need to. All right, let's go ahead and get started. All right, let's talk about these two polygons here. Would you copy these in your notes, please? Let's talk about these two polygons. First of all, this polygon to my left here is called a convex polygon. Convex. This polygon over here is called a concave polygon. Concave. Okay? Now here's the difference between the two. Notice over here on the concave how two of the sides indent back inside the polygon like this. So in other words, when you draw the polygon, you're drawing your sides, and all of a sudden you indent in and then come back out and then finish drawing. And the way you can remember this is it's like a little cave right here, a little opening in a rock, a cave. We call it a concave. It's like a cave right here, and that's an easy way to remember that. If you're not quite understanding my definition, what I'm saying, let me just explain it to you this way, okay? I don't care where you draw a straight line through this polygon over here. You can draw a million straight lines. I don't care where you draw a straight line, it will go through exactly two sides, always. Do you see that? I don't care where I draw a line, it'll go through two sides. 1, 2. Two sides. If I draw a line here, it goes through how many sides? Two sides. So anytime you draw a line that goes through the interior of a convex polygon, it will touch two sides or two vertices. We won't get into that now. But look at the concave. Yes, it's true if you draw a line here, it intersects two sides. And yes, it's true if you draw a line here, it intersects two sides. But if there's just one place that you can draw a line that intersects more than two sides, then it's a concave polygon. Look at this. If I draw a line right here, look how many sides it intersects. 1, 2, 3, 4. That's definitely more than 2. And so I know that I have a concave polygon. So let me word it to you this way. You know that you have a concave polygon if there is at least one place where you can draw a line that intersects more than 2 sides of the polygon. Over here, there is no way you can draw a line anywhere and have that line intersect the polygon here more than 2 times. I don't care where you draw the line, every line you draw through the interior of this polygon is going to intersect 2 sides. So we're looking at convex and concave polygons, okay? I hope that makes sense. Now let's continue on, let's practice this. Go ahead and do the best you can to draw this figure in your notes. And I want you to answer a question for me. Is this concave or is it convex? Is this concave or is this convex? Well, if I can draw one line, only one, if I can find at least one line that when I draw it, it intersects the polygon more than 2 times, then I know that it's convex. Well, if I'm looking, I've got to see if I can find a line that does that. I find more than one. Here's one here. If I draw a line there through the polygon, notice it intersects the polygon in 4 places. 1, 2, 3, 4. And I've got another one. If I draw a line right here, that line that I just drew intersects the polygon in 4 places too, which is more than 2. So 1, 2, 3, 4. So this polygon here is what we call a concave polygon. Okay, and you can see the indentation right here, and you can see the indentation right here. That is a concave polygon. Pretty simple, isn't it? Let's try another one. Is this a concave or convex polygon? Which is it? Well, let's take a look and see. I'm trying to find a place somewhere on this polygon that if I draw a line through the interior of the polygon, the line that I draw will intersect more than 2 sides. I just can't find it. I don't care where I draw a line, it's going to intersect exactly 2 sides of the polygon. 2 sides. Okay? There is no line anywhere that you can draw that goes through the polygon that intersects more than 2 sides. So this is what we call a convex polygon. There's no indentation like there was back here. Okay? This is a convex polygon. All right, let's continue on. Now, I'd like you to write this in your notes. It'll be on the quiz, just so you know, this Friday, so you'll need to know this. Equilateral polygon. Equilateral polygon. What is an equilateral polygon? Well, let me ask you a question. What's an equilateral triangle? Isn't an equilateral triangle a triangle in which all the sides are congruent? So what is an equilateral polygon? A polygon in which all of the sides are congruent. Like this, if you want to write this down. Let's go ahead and call this side here a length of 6. We'll call this a length of 6, this also, and this also. So we would call this an equilateral pentagon. Okay, equilateral pentagon. And there we go. All right. Now it's called an equilateral pentagon because all of the sides are congruent. All of the sides are the same. They all have a length of 6. Okay? Not bad. All right. How about an equiangular polygon? An equiangular polygon. Well, what's an equiangular triangle? Wasn't that a triangle that had 3 congruent angles? So what do you think an equiangular polygon is? A polygon in which all of the angles are congruent. All of the angles are congruent. So if you want a picture of that, here's an example. A rectangle would be a good example. A rectangle is an equiangular polygon because if you have a rectangle, you have 4 right angles. Let me get a quick drink here. And if you have 4 right angles, then you have 4 congruent angles. all of the angles are congruent. Do you understand this? Equiangular polygon, a polygon in which all of the angles are congruent. Pretty simple. All right, you'll need to know this also, of course, for the quiz on Friday. Now, what about this? What about a regular polygon? Well, a regular polygon is a polygon that is both equilateral and equiangular. So in other words, it's a polygon in which all of the sides are congruent and all of the angles are congruent. And we call this a regular polygon. Sorry for the yawn, excuse me. So if you want to get a picture of this, go ahead and write this down. We're going to go ahead and put marks through all the sides. There we go. So now we know all the sides are congruent, and we're going to put these symbols here in the angle, one mark on the angles also. Okay? So there we go. All right, so this here is an example of a regular polygon. As soon as you know that you're given a regular polygon, then you know that all of the angles inside the polygon are congruent and all of the sides are also congruent. Okay, pretty simple. It's not difficult. All right, and I told you this video wouldn't be very long, but that's why we're also doing homework this class hour. Okay, and so here would be an example, another example. Well, I'm sorry, I apologize. I know what I wanted you to do. I'm asking you to take a look at this, please. And I'd like you to quickly draw this in your notes if you would. Would you please do that? And then answer this question for me. Is this a concave or convex? First of all, answer that question. Polygon. And then is it an equiangular, equilateral, or regular polygon? So let's see. First of all, we can tell it's not concave. There's no indentations like that in the polygon. So we know this is convex. So we have a convex polygon. And now, would it be regular? Would it be equiangular, equilateral? Well, I notice all of the angles are congruent, but I notice that all of the sides are not congruent. Notice I have 2 marks here and 2 marks here. So these 2 sides are congruent, but these 2 sides are not congruent to all these other sides. All these other sides just have 1 mark. So are all of the sides congruent? No, but all the angles are. So we're going to call this an equiangular. An equiangular convex polygon. Or you could also call it an equiangular hexagon because it has 6 sides. Either way, the main thing is that I want you to be able to do is tell me, is this an equilateral, equiangular, or regular polygon? Okay? All right, let's go on and try another one. All right, how about this one? Go ahead and copy this in your notes if you would, please. I'm going to move on, so you might have to pause the video. Is this equiangular, equilateral, or regular? Well, I notice all of the sides are congruent, so it's definitely equilateral. I notice all of the angles are congruent, so it's definitely equiangular. So whenever a polygon is both equiangular and equilateral, we call it a what? Do you remember? We call it a regular polygon. In this case, we could call this a regular hexagon because there's 6 sides, so thus it's a hexagon. So we have a regular hexagon. Okay? All right, let's continue on. All right, how about this? Let's take a look at this. Go ahead and copy this in your notes, please. I'm telling you that I have an equiangular polygon. It's equiangular. This is so easy, students. So if I'm telling you it's equiangular, that means all of the angles are congruent. So that means this angle is 110, this angle is 110, this angle is 110, and this angle is 110. So that means this angle right here, 2x minus 6, has to equal what? That's an angle, isn't it? So let's solve for x. Doesn't it have to equal 110? It should. If it's equiangular, which I'm telling you it is, that means all the angles are congruent. And if all the angles are congruent, then 2x minus 6 has to equal 110. Let's bring this 6 over and make it a positive 6. So now this 6 is gone. And we're left with 2x equals 116. Now we're going to take 2 and we're going to divide both sides by 2 and we're going to be left with 58. X equals 58. So there we go. That's really pretty simple, not very difficult. All right, let's continue on. Now, like I said, short video today, so enjoy that, but you got homework to do, okay, and a decent amount of it. Now, you might finish before the bell rings, that's fine, but your homework is due tomorrow. Now, first of all, I need to see if I can't do something real quick here. I cannot, okay. I want to remind you that you have 3 definitions that you need to write 3 times each. Now I'm going to admit something to you. I have not done a good job keeping track of that, and that stops today. So some of you have been doing them, some of you haven't. When Mr. Earhart, when I say that, it just happens. It stops today. From now on, I will be taking points, and a good amount of points, off of your homework if this is not done. So you need to do this page and these numbers right here, and then write the 3 definitions 3 times each. What were those definitions? Well, I'm glad you asked. One was equilateral polygon, one's equiangular polygon, and one is a regular polygon. Okay, so those are the definitions. I want you to do page 413, numbers 10 through 21 and 33 through 38. Here's the video that will help you. And now, can I say something? Some of you still email me sometimes, which is fine, but listen to me. Don't listen. See this video right here? I'm going to grab it. I'm going to move this video right here. This video, Geometry 8.1 homework. This video right here. You can't listen to everything that it says. I made that video last year. Okay? I made that video last year. Don't listen to anything that it says about quizzes, tests, homework coming up, homework being due. Ignore all of that. All that you're doing is listening how to work out each problem. Okay, that's it. All right, call me or email me if you have any questions. I'm here to help you. Hope you guys have a good day, and I will talk to you tomorrow.